Sound occurs only because of vibrations. When there is vibration, sound is created. And if sound is created, that time there is vibration. Sound and vibration both are interdependent on each other. Any one cannot occur without the second one. When one occurs, sound, vibration is there, and when there is vibration, there is creation of sound. You must have experienced when playing a tabla or when playing a guitar. If you pluck the string of a guitar, you will feel the string of the guitar starts vibrating. It starts going up and down in a fast and a rapid speed. So those are called the vibration. What about if you just slightly tap onto the diaphragm of tabla? What do you feel? The diaphragm of tabla starts vibrating. This diaphragm will vibrate very rapidly, but at a very small distance or at a very small height up and down through the tabla. So that too is a vibration. In short, without vibration, sound cannot be created. While playing any kind of musical instrument, the motion of that vibration is at a fixed period of time, again and again repeating. So when they are at a fixed interval of time, it is called as a periodic motion. Oscillator, oscillation and oscillatory motion. In garden, there are swings. Yes, a pendulum also goes in oscillatory motion. Moving of an object up and down repeatedly, or moving of an object to and fro. To and fro means back and front. Again and again repeatedly, that kind of motion is called as an oscillatory motion. A pendulum of a clock moves in oscillatory motion because at one time it goes to the left side, at the other time it goes to the right side. From the center, the left side and the right side, both the distances are equal. That is called as the oscillatory motion. When it completes one round, it is called as oscillation. When it completes one round, it is called as oscillation. And that particular object which moves in oscillatory motion is called the oscillator. In a clock, a pendulum is a oscillator. In a garden, the swing is a oscillator. What is an amplitude now? The highest distance between the center of the oscillation to the left side or the right side. That means the longest or the highest distance between the center and the oscillation, last point of the oscillation, that is called the amplitude. In the figure on the textbook page number 120, you can see the third diagram with a ball A where its end is tied at point O and the ball goes from the left side to the right side at point C and point B. At that point, you can see the amplitude is the distance between point A and point C or point A and point B. That is the highest distance between the center of the oscillation and one of the side of the oscillation. So that is called as the amplitude. And the complete one circle, when it finishes one circle, it is called as the oscillation. One round is called as the oscillation. Time period of oscillation and frequency. One round of an oscillation requires certain time. Yes, for example, in 1 second, there are 10 rounds completed of an oscillation. 10 times a ball is going up and down. So that is the frequency of that ball, frequency of that object. The formula to find out the frequency is 1 upon T. T means time and N means frequency. Frequency is calculated in the terms of hertz. When the time has unit seconds, The time has unit minutes, so frequency has the unit hertz. It is indicated as Hz. The time period of oscillation depends on the length of the pendulum. The time period of oscillation increases if the length of the pendulum is increased. The frequency remains the same even if the amplitude decreases or increases. Why is it so that the frequency remains same? Frequency means number of oscillations per second per unit time. Why is it same? Why not it is increasing if the amplitude, that is the distance between the one end of the oscillation and the center, is less than 2, the frequency remains same. When the amplitude is more, at that time when the pendulum comes down, trying to come to the center of the oscillation, it will come faster as compared to when the amplitude is less. When the amplitude is less, that time the ball or the pendulum will not come that faster as compared to when the amplitude is more. That means more distance is covered faster and less distance is covered slow. But the distance covered in both the conditions, more distance or less distance, the period remains same. The time required by the distance to cover more amplitude and the time required by the distance to cover less amplitude is the same. That is why the frequency remains same. With the help of the formula 1 upon T is equal to F, frequency is equal to 1 upon T, we can easily find out the frequency with the help of T. And if we want to find out time T, we have to do just 1 upon F. When cross multiplied, the formula of T comes as 1 upon F. Next point is high and low pitch of sound. Most probably, you will experience the high and low pitch of sound with the musical instruments which have strings, like guitar, tanpura, santur, etc. With these instruments, you will experience the different vibrations, the different frequencies through it. Depending on the vibration, it will create the sound. With the long vibration, it will create the different sound as compared to with less vibration or the short vibration. That is, when the amplitude changes of a vibration of an oscillation, at that time you will get the high and the low pitch of sound. When tension in the wire is increased, the frequency is seen to increase, and when it is reduced, frequency is also seen to decrease. The unit for the sound level is decibel, indicated as dB. Loudness or softness of sound is indicated by two terms, namely intensity of sound and sound level. When speaking loud, when speaking soft, so that is the sound level. These all things depend on the amplitude of the vibration, on the amplitude of oscillations of the sound. Audible sound. Audible means the sound which can be heard. The frequency of sound audible to human being is between 20 Hz and 20,000 Hz. We can easily hear sounds in this frequency range. The sound which has the frequency less than 20 Hz or the frequency which is more than or greater than 20,000 Hz, that is not audible to human beings. Infrasonic sound. Have you ever heard the sound of the movement of our hands or of the movement of leaves falling from the tree? That is called as the infrasonic sound. Infrasonic sound is different as compared to the normal sound. A sound with a frequency less than 20 Hz is called infrasonic sound. Sounds with a frequency less than 20 Hz are produced by some animals, namely whales, elephants, and rhinoceros. They only create infrasonic sound. They are less than 20 Hz of the frequency. The frequency is less than 20 Hz. Ultrasonic sounds. A sound with a frequency higher than 20,000 Hz is called ultrasonic sound. Human beings cannot hear such sounds. However, some animals, for example a dog, can hear such sounds. So in general, the sound whose frequency is less than 20 Hz is called the infrasonic sound. The sound whose frequency lies between 20 Hz to 20,000 Hz is the audible sound which we human beings are able to hear. And the ultrasonic sound is the sound whose frequency is more than 20,000 Hz. We can hear only the sound which is between 20 to 20,000 Hz. Not even below the 20 Hz, not even above 20,000 Hz. We can hear only audible sound, not infrasonic sound and not even ultrasonic sound. Infrasonic sound and ultrasonic sound are heard only by some animals. Thank you.